Hi. So today we're going to have a short lesson on page 172 to 174, and we're going to be talking about the first section in our new unit for chapter 3, which is over linear relationships. So I'm going to start off just by going through some of the examples, and then you need to use these examples to complete an assignment out of the book, okay? So in this first part, it's talking about linear relationships. So we know that linear relationships that have straight line graphs are called linear relationships. I think I just said that. Anyway, notice if you look at the pattern here, the y value, the y variable is going up by 2 each time, and the x variable is going up by 1 each time. So because it has that constant rate of change, that constant same pattern, we look at that and call it a linear relationship. Now, this linear relationship has a constant rate of change, which is an actual fraction. It's a value. So in this particular example, the rate of change is 2 over 1. When we write the rate of change, it's always going to be y over x, okay? So if I look here at this example, we have a table. Notice that I have labeled the first column x and the second column y. It always goes alphabetical when you look at a table, okay? So we can see here as the balance decreases each time by -30, the number of transactions increase by 3 each time. So this is a constant rate of change. As the y is going down by 30, the x is going up by 3 every time. So because it has a constant rate of change, we say this is a linear relationship. The constant rate of change can also be written as the change in y over the change in x. So in this case, it's going to be -30 over 3, which can be simplified to -10. So this means that in this particular case, that each transaction involved has a $10 withdrawal, a -$10 value. So when you guys look at examples, either in a table or in a graph, we're looking for that linear relationship. If it has a linear relationship, then we can write the constant rate of change as a fraction, y over x. Let's look at some different examples here. I'm going to kind of make each example a little bit larger. So if we look here at this first example, we can see that we have the x value and the y value. Again, it's going in order alphabetically. And when we look down the pattern for the y value, we can see that at first it starts subtracting 5, but then in the next one it's subtracting 4, and then in the next one it's subtracting 4. So this is not a constant rate of change. It has to be the same every single time you look for that pattern. So since this is not constant, we would say that this is not a linear relationship. That means we do not have to look for a rate of change because it is not linear. Now, the other side of that is looking at a graph. So if we look at this example, first we had a graph with 3 points. So I can erase that there. I can see those 3 points. So what I did is I made an XY chart and I wrote those 3 points as ordered pairs. So for example, this point right here, we would go over 8 and then up to 80. So I have 880. Then the next point is located at over 16 and up 60. And then the third point is located at 2440. So I wrote those here in my XY chart. I can see that they form a straight line. If we were to connect those together, it would form a straight line. So I know that it is a linear relationship. Then I can look here at my table and I say, okay, well, the y is going down by 20 each time, and the x is going up by 8 each time. So I know my rate of change is going to be the change in the y, which is negative 20, over the change in the x, which is 8. So we would write that fraction as negative 20 over 8, and that can be simplified to negative 5 over 2. Now, we leave the rate of change as a fraction, even if it's an improper fraction. We want to leave it like that, but we can simplify it. So we have two examples here. One is in table form, one is in graph form. But what we're doing in both is looking for a pattern to see if there is a linear relationship. And then if there is, we're looking to see what is the rate of change. So what is the change in the y value over the change in the x value? And that is what we write as a fraction. So on the first part of your assignment today, you're going to be looking at tables and graphs. And you're first going to determine, does it have a constant rate, a constant pattern? If it does, then it's linear. And then if it is linear, you're going to determine the rate of change by the change in the y pattern over the change in the x pattern. So that's the first part. The second part today is to look at proportions. And if you remember from previous grades, a proportion means that we have basically two fractions or three fractions or four, whatever, that all equal the same thing. So I've just put an example up here to kind of refresh your memory. So 2/4 equals 4/8 equals 1/2. That is considered a proportional relationship because they all equal 0.5. So in a proportional relationship, if all the fractions, even though they might look different, but if you divide them and they all equal the same decimal, then you know that they're proportional, and that's what we're going to be looking for today for the second part of this lesson. So if we look in this example here, right from your book on page 173, the first part of this example shows us a pattern here. Sorry, I'm going to change a few things, but that's okay. Kind of got out of whack here. Okay, so if we look at this example, I'm going to kind of just bullet point some things. First of all, since the rate of change is constant, we can see here, would be my x value, this would be my y value. And when I look across, I can see my x is going up by 5 each time, and my y is going up by 9. So because it has that constant rate of change, we can say that it is a linear relationship. Now, if it's a linear relationship, we can then write our fraction, our constant rate of change, as a fraction. So in this case, it's always going to be your y over your x. So 9 over 5 would be our constant rate of change. That's the pattern that we see. Now, the second part of this, I'm going to do another bullet point here, is to determine if these are proportional. So in order to do this, we're still going to take the y over the x, but now we're looking at specific points inside the table. So we have a pattern on the outside, which is for your constant rate of change. And then on the inside of the table, we have a pattern also that we can look at. So if we look here, we're going to take the 41 and we're going to put it over the 5. So that's what they did here, 41 over 5. if it will let me. So here's 41 over 5, and we can go ahead and say the y over the x, 41 over 5, equals 8.2. Now we can do it again with the next set. So I can take the next one and do 50 over 10. Well, 50 over 10 is 5. So I can already see that these two are not the same. They are not proportional. The book also goes further and does the next one, 59 over 15. We can also see that that is not the same. So since the ratios are not the same, the relationship between degrees Fahrenheit and Celsius is not proportional. So these have to be the same decimal or whole number for it to be a proportional relationship. Now let's also look at this as a graph. So I'm going to move this up here. So if we look here in graph form, there's another point I want to make known, and it's right here on this last sentence. So I'm going to put a bullet point here as well. The line containing these points that are in the table right here. So they took these points and they made it into a graph. And we can see that they, if we continued this line on the graph, like so, we can see that it does not go through the origin. It does not pass through the origin. Remember, the origin is right here. The origin is considered 0, 0. So this graph does not go through 0, 0. That means that this is not a proportional relationship. So if you have a hard time seeing the proportional relationship in a table, then you could graph the points on a piece of graph paper, and you could see if the graph would go through 0, 0. If it does go through 0, 0, it has to be a proportional relationship. So that's another way to check to make sure that it works. I'm just going to erase that part. Kind of moved on me. Okay, so this is the second part of your assignment. It's going to be able to look at a graph or look at a table and see if that relationship is proportional. So now your job is to take this information and practice it on your own with an assignment out of your book. So you'll need to go to my website and the assignment will be there, and I'd like you to try that for tomorrow. Okay, have a good day.